For the next figure, figure number 3, the V is the node voltage. Again, you have to find the node voltage for the nodal. So from here, when the current is entering the resistor, the polarity of the voltage will be positive and the negative. The positive voltage will be V. At negative, the voltage value will be 0 volt for the ground side. Therefore, by using the Ohm's law, the voltage at the VR here, I is equal to VR over R. So VR is a positive voltage minus negative voltage, V minus 0 over resistor. So V at a positive minus the V at a negative. For the figures number 4, so you can see here there is a voltage in between the resistor. The left side will be V1 and the right side will be V2. The current is entering from the left to the right. So here is the polarity. Again, by using the Ohm's law, positive minus negative over resistor. For the next figure, if the branch do not consist of resistor, do not use the Ohm's law formula in order to find the currents, because the current is already given in the branch. So you can use the values of the currents, but you have to consider either the current is negative or positive. If you are assume that the voltage is the voltage exit the node is positive, as I mentioned previously, we assume all the currents is exit, and then you can see that the current is at a positive is a reverse direction with the current source that in the branch. So it means that the current will be negative. This is your assumptions. This is the current source directions of currents. And then for the next figure, you can see that the arrow of the currents directions is same as the current source direction. So we just assume that the currents is equal with the current source directions. So in this branch, you can see that there is a source and also the resistor. So it means that you have two voltage. First is the V, the node voltage, and then the supply voltage, and then you have a resistor. So please remember that you can find the I using the Ohm's law if the branch consists of resistor. If the branch do not consist of resistor, you cannot apply the Ohm's law. So from here, we label the A as mentioned in here because he wants to know the left and the right sides of your resistor, here and here. So from here, the current is exit the voltage, and then the polarity of the resistor is marked like this one. And then same at the first figure, you have to find the A, which is V at a positive minus with A at a negative here equal to Vs, and then you get the A equal to V minus Vs. So for the I that flowing through the resistor, I here, use the Ohm's law, which is positive minus with the negative. So positive is A, negative is 0. And then you substitute the A into the equation. Then this is the answer for this figure. Then for the final figure, if the branch only consists of the source, which is do not consist of a resistor, so you cannot use the Ohm's law in order to find the I. So Ohm's law is equal to V over R, but there is no R in the circuit, so you cannot use the Ohm's law in order to find the I. So from here, this one is a gift actually. Yeah, this is a tricky. If you have this kinds of circuit, you don't have to do the summations of currents at that node. Actually, your attention is to get the V, and then the circuit is already give you the V. It means that you already know the voltage at the branch, so don't need to apply the KCL at that branch. So now you can get the answer, the node voltage. So if the branch consists of these types of combination, please do not do the KCL as need not, because the node voltage is already given. Okay, so actually this one is same as the first and the second figure. Actually, it just move the resistor or creating two resistor in one branch. Actually, you can add the resistor so that it will become like this one. So plus minus here, I is equal to V minus Vs over R1 plus R2. Or if this one change the polarity like this one, so it will become I V minus Vs over R1 plus R2, so it will become V plus Vs over R1 plus R2. So in order to test your understanding, please do the exercises by finding the A, B, C, and D, and then after you done these exercises, we will discuss about this one. Thank you.